Hi all, today we discuss fundamental theorem of calculus. So this is the statement: if f belongs to R on AB and if there is a differentiable function capital F, that is the antiderivative of this small f, such that f dash equal to f, that is the definition of antiderivative, then integral a to b f of t dt will be capital F of b minus capital F of a. So this is what we call fundamental theorem of calculus. Okay, we prove this theorem starting with the definition of the integrability of this small f. From this f belongs to R, we can get for any epsilon greater than 0, for every epsilon greater than 0, there is a partition P belongs to AB such that UPF minus LPF less than epsilon. Okay, so this is proved in theorem 6.6 in case of Riemann-Stieltjes integral. So that is also true for Riemann integral. So this is the characterization or definition of, or this can be considered as a characterization of Riemann integrability. Now if this happens, then theorem 6.7, the C part or B part of 6.7 shows that if we get any points ti from xi minus 1 comma xi, for those points we can define some special sum, that is f of ti into delta xi. In fact, that is delta alpha I. So this I is from 1 to n if that partition contains n plus 1 points. So this sum tends to this integral. Okay, that means this minus integral a to b f of t dt will be less than epsilon. If 6 point in the statement the 6.6 happens, then this is also true. Okay, so this is discussed in 6.7, theorem 6.7. So if we choose any points ti from this subinterval, then for any choice of this ti, we have this sum is also very close to this integral a to b f of t dt. Okay, so now we consider this these two theorems, then apply this to this capital F dash. Okay, so we know that this capital F is differentiable. Then if we consider any subinterval xi minus 1 xi, then we can write this capital F of xi minus capital F of xi minus 1 divided by xi minus 1 is equal to capital F dash of some ti, for some ti in between the closed interval xi minus 1 xi. So this is the consequence of the mean value theorem, or the definition of mean value theorem. And if you rewrite this as f of xi minus f of xi minus 1 equal to, this can be replaced by delta xi, and this is small f of ti, because we are given that capital F dash is small f. So this is small f of ti times delta xi. Okay, now if we collect all these equations from each of these subintervals, then add all these, you can get, if you add, this is also true for I equal to 1 to 3 etc n, and sum up all these equations, you will get this will be f of x1 minus f of x naught, that is equal to f of t1 times delta x1 plus etc etc. Finally we have f of xn minus f of xn minus 1 equal to f of tn times delta xn. When you sum up all these, you can cancel this f of x1, f of x2 and all the way up to f of xn minus 1. Then remaining will be f of xn. F of xn is in fact f of b minus f of x naught, that is f of a, that is equal to, the right side will be summation I equal to 1 to n f of ti delta xi. This will be the right hand side. So from this equation you can replace this sum by capital F of b minus capital F of a. So that will be that modulus becomes capital F of b minus capital F of a minus integral a to b f of t dt. Okay, that can be made less than epsilon for any positive quantity epsilon. If you start with a positive quantity epsilon greater than 0, then this quantity is difference between modulus of difference between these two will be less than epsilon. So this implies integral a to b f of t dt is same as capital F of b minus capital F of a. Okay, so this proves fundamental theorem of calculus. Okay, now there will be a product rule in integration, so that is known as integration by parts. Next we will prove integration by parts, the formula integration by parts. This is the integration by parts. We have used this formula in several occasions in your +2 classes. We prove this formula here. So this for the proof we put h of x equal to capital F of x into capital G of x. Okay, then what is the derivative of this? The derivative of the capital H is denoted by the small h. Then what is small h? That is the derivative of capital H of x. That will be using the product rule of the differentiation. We will get this f dash of x into g of x plus f of x into g dash x. So this is the derivative of capital H of x. But we know that capital F dash is denoted by small f. So that will be small f times small f of x times capital G of x plus the next will be capital F of x times small g of x. But we know that the small f, capital G, capital F, small g are all this integrable functions on AB. So this belongs to R. Okay, in fact this h dash is a integrable function. So this small h of x is an integrable function. So we write integral, we know that we have already proved a theorem, integral fundamental theorem of calculus, that gives integral a to b f of x dx equal to f of b minus f of a. We apply this theorem for this function small h of x, then that will be integral a to b h of x dx. What is integral a to b h of x dx? By definition, that is by that theorem, that is a capital H of b minus capital H of a. Okay, now we observe the consequence of this equation. So this implies integral a to b. What is h of x here? H of x is this small f of x capital G of x dx plus integral a to b. Again, this is capital F of x capital F of x small g of x dx equal to h of b minus h of a. What is h of b? H of x is defined as this product of f and g. So this is f of b g of b, that is h of b minus h of a. What is h of a? F of a g of a. Okay, now you rearrange this terms, then that will be we write the second term on the LHS first. So that will be integral a to b capital F of x small g of x dx. So that will be equal to we transpose this term to the right hand side, so that becomes the right hand side. The right hand side we have already f of b g of b minus f of a g of a, f of a g of a, and we have minus of this term, minus integral a to b capital small f of x, right, small f of x capital G of x dx. So this is what we have to prove. So this is the formula what we call integration by parts. So this can be observed like this f of b minus f of b g of b minus f of a g of a is that is integral a to b this capital F times capital G. So that is in fact this is we interpret this as integral of we write this as capital F of x times integral this capital G can be written as integral g of x dx from this a to b. Okay, so we write this this is this capital G can be considered as integral this, so we minus of this time integral a to b f of x g of x dx. This g of x can also be written as integral integral g of x dx. Okay, so we can replace this. Now we can call this integral a to b f of x first function into second function dx can be written as first function into integral of second from a to b minus integral of first function derivative of first function into the integral of the second. Okay, integral of the second is this one. Okay. So we can interpret this as the our so-called integration by parts. So this proves theorem 6.22. In the next class we will discuss some integration on some vector valued functions. Okay, so with that we can conclude this module.